Good morning, I am David Norris, and given the business that I want to establish in Western Africa, I've decided to just give a brief introduction to the pros and cons of photovoltaic power, both from a local perspective as in the more general perspective, and basically set out my plans. And of course, feel free to get in touch with me later on if there are any questions that you might have. Contact details will be provided. Now, the long-term plan is to develop and market low-cost solar photovoltaic is a technical name energy devices in Western Africa. The business is, at least in the first instance, to be family run. It will also, in the first instance, be small scale. That is by necessity because, after all, as the saying goes, you cannot build Rome in a day. Now, the base technology. Most solar panels are either made of polycrystalline or monocrystalline silicon. So this is basically to do with the way they are set out, but let's not go too much into the technical details. It's not really what I'm here to talk about. Let's have a look at the practicalities. The standard solar panel under a clear sky in a low latitude, we are talking about roughly 12 degrees north of the equator here, has an input rate of around 1,500 watts per square metre. That's compared with, for example, about a kilowatt, which is the best you could expect in the weaker sunlight of Europe, and the majority of solar panels available currently have an efficiency of around 15 to 20%. They are improving, however. Now, if your solar panel were 1 square metre in dimension, then it would likely produce around 225 to 300 watts in direct sunlight. Direct sunlight, by the way, means under a clear sky and without obstructions, so that really is best possible case. Now, let's have a look at some of the numbers here. Power yield or consumption is measured in watts. In a DC circuit, power in watts is voltage times current, so that's volts times amps to keep it simple. So, for example, 200 watts as a ballpark figure will power a small television. 10 watts is a standard USB charging output. The standard is a regulated 5 volts at 2 amps. 200 watts will charge 20 USB devices on fast charge simultaneously. And of course, heating applications, which have powers rated in kilowatts, are simply not required in Africa. Some typical ratings for irradiance. I'm not going to read all these numbers out, but feel free to pause or go back through these just for a rough idea. But these are the typical outputs from various solar panels, and I'm not going to go too much into the technical details, but let's just say that solar panels do, however, tend to become less efficient if they get too hot. That's an engineering challenge because Africa is quite a hot environment, as we well know, and of course solar panels, of course, can't be painted white or anything like that to prevent overheating, and they have to be in full sun to do their job. So, let's have a look at the customer side of things. What would the customers expect as a return on investment? Well, one major goal is reduce living costs. For example, if you were using solar energy instead of a diesel or petrol powered generator, you will not be constantly paying for fuel, which of course, as we well know at the moment, is going up in price almost exponentially at the present time. Improved quality of life. Now that is a very broad statement, so let's just have a quick look. Let's break that down. It can facilitate participation in modern society. After all, no technology works without power. And it's at £1,000, $1,000 plus iPhone is just a useless paperweight if you cannot charge it. Improved opportunities for education. Well, improved communications certainly provide that. Improved communications are a sort of outline of the whole thing, but think about the implications. It means you'll be in touch with relatives all over the world at any time, even if the end of a power outage. Improved disaster resilience. Well, again, being able to call for help or maintain communications after, for example, an extreme weather event, it is an obvious necessity. Think, for example, of the aftermath of natural disasters such as the Boxing Day tsunami in Asia in 2004. I remember it well. There are plenty of opportunities for education in renewable technologies also. Now, fulfilling customer needs, of course, is going to be vital, naturally. So, keeping costs to the absolute minimum is a key concern, as will be linking the product attributes to customer needs. Now, with current solar panel costs running at around $0.50, actually more accurately 25 cents, a quarter of a dollar per watt, small-scale deployment is a practical solution for most. Now, China is currently the most cost-effective place to obtain parts. The Pacific Rim more generally, but the sources I have used for previous projects are located in China. Large scale communal facilities. These are an idea I have, but I will be giving this some consideration. I'm essentially thinking of ways of dividing cost of things, because the solar panels and the storage batteries are actually the most costly components, and if there is a way to share them, then we can greatly slash the cost per customer. But let's have a look at this later. Most of the designs I have are independent of main supplies. The uninterruptible power supply that I demonstrate later is one of the few exceptions. Now, when it comes to cost analysis, we need to indicate the long-term financial advantages for the customer. We need to show them what kind of return they will get on their initial outlay and on what timescale. We need to promote education and awareness of new technology. Obviously, in a place such as Western Africa, we're talking about technology which many local people will not have seen before, and therefore initially they won't know about or trust it, so education and awareness is vital. As we'll be monitoring the changes in customer requirements, as new technologies come along, so do new ideas, and therefore we will have to stay abreast of that. And obviously, if products need to be modified or developed at a later stage to take this into account, we will need to accommodate. we also need to take advantage of evolution in the underlying technology. For example, if there is a more cost-effective design of solar panel, then of course newer designs are going to reflect that. Now let's have a look at the one and only advantage of carbon fuels. They're well known and established, and infrastructure, where any exists at all, is already in place. Now, I would, in, for example, the 1970s, have been saying they are low cost, but they are certainly not low cost today, and as I speak, they seem to be getting more and more expensive every day. In the United Kingdom, for example, average energy bills have increased from about 1,300 GBP last year to a projected 3,300 GBP plus in a few months' time, just in time for winter. I can't think of any advantages other than that they are established and well known about. Now, there is of course a whole list of disadvantages of carbon fuels. They have a high initial cost. After all, a new generator is not cheap. There's a high ongoing cost. Of course, a generator that requires hydrocarbon fuel has to be filled up on a regular basis. Once you have used a tank of fuel, you can't use that tank of fuel again. It has to be refilled. Now, as we know, burning fossil fuels produces a lot of air pollution. Particulates, oxides of nitrogen and the such like on the local level are unpleasant local pollutants that can cause many health issues, respiratory illness being an obvious example. When you look at many people in the slums in different places, they are using these generators in close proximity to other families, and the health detriment is clearly apparent. Constant carbon dioxide emissions are, of course, changing the climate, a problem we have known about for many decades, but are only now, just now beginning to take seriously, when it may even be too late to stave off the worst effects. Of course, the price of carbon-based fuels will be highly vulnerable to events elsewhere in the world, as we are learning the hard way here in 2022. Well, let's get through the disadvantages of photovoltaic energy. We have to be honest. New technology which is unfamiliar to local residents, many may not have seen or heard of this technology before, will have to be demonstrated and promoted, and of course that means education is key. High initial cost may be a problem, so keeping these costs to an absolute minimum will certainly be key. Sourcing photovoltaic panels and other components from the Pacific Rim is by far the most cost-effective way to source them currently, and it's likely to be the case for the foreseeable future. Solar panels currently working at around 25 US cents per generated watt, so obviously I'll be monitoring developments in this area. So definitely at present smaller scale devices are more affordable on a per customer basis, but I'm thinking about the development of some communal designs in order to take advantage of economies of scale. It may be that one communal solar panel, which is used to provide power to a large number of devices, could be far more cost effective than everyone having smaller scale devices and individual panels, of course. Let's just have a look at the basics of the technology. Most of the designs I have currently are based on the microcontroller, and there are very sound reasons for this. Microcontrollers can work out as dollars a piece when ordered in bulk, compared with tens or even $100 plus for a microprocessor. They have very low power consumption. A microprocessor will consume something like 15 watts of power, whereas microprocessors' consumption is measured in milliwatts. They are much more tailored to the application. Without going into the technical details, they have built-in analog to digital conversion capability, which makes them much easier to deploy in control and monitoring applications. Most of the firmware I write for the microcontrollers will be written in C. Stepper motors are motors which step only in discrete steps, and these are excellent for this application as they provide very accurate control of movement and alignment. A typical stepper motor steps in increments of 1.8 degrees, or that's 200 steps per one rotation. A built-in inverter converts the photovoltaic power, which is originally direct current, to AC, alternating current, like the main supply. Now, backup batteries obviously need to be managed and maintained, and I can write the means for doing this into the firmware for the microcontroller. When it comes to keeping solar panels aligned at the sun, aligned on the sun, should I say, there are two approaches: a time-based approach, or there's something called MPPT, which stands for Maximum Power Point Tracking. Remote control and monitoring of a communal facility is certainly possible, and I do have that capability. So let's have a look at some practical applications for the end user. Solar power storage. This will require battery storage for use in the hours of darkness, is an obvious requirement. Uninterruptible power supplies. These basically provide backup power for devices like computers, for example, to keep you operational during times of mains power failure. Automatic lighting at night is a definite help. As a father, I know what it is like to have to wake up and feed a baby in the dark in the middle of the night, and obviously having some automatic lighting will be a definite help. Home automation is a definite possibility I'll be looking at later. Remote control and monitoring is a distinct possibility. If I develop communal solutions later, then this would certainly be an advantage. Photovoltaic to AC inverters are built into many of my designs, or they can be standalone. An inverter is something which converts direct power, for example, from a dry lead acid battery to alternating current as used in the main supply. Normally 230 volts will be the target voltage as it is standard in this region, but as a few examples, China uses 220, Australia 240, Japan is the world's lowest at 100 volts, the United States famously uses 110, and 230 is the standard in European countries. Changing the output voltage is a minor modification. It really is. Now, this is just a brief example. I won't go into it too much, but this is an example of an uninterruptible power supply. It maintains a charged backup battery bank On failure of the main supply, switch over to backup power is automatic. A low battery warning is included. This will indicate that you are running on battery power because the main supply has failed. Built-in inverter outputs 230 volts AC. There's automatic recharging when the main supply is restored. You automatically recharge the backup batteries, and this is actually one of the very few designs utilising the main supply and which is not solar powered. Of course, we are going to be definitely wanting a low battery alarm included, so if the mains power outage is prolonged, then you've got the opportunity, for example, to save things and shut computers down cleanly so you won't be suddenly blacked out and lose your work. So, finally, the overall conclusion here. In the longer term, advantages of solar power, photovoltaic if you want to get technical, clearly far outweighs the disadvantages in the longer term. High initial cost, however, is an obstacle which needs to be addressed and overcome. Training will require much thought and planning, and this is due to the demographics of the local population, details to be announced. I've given some thought to providing training for non-English speakers also, incidentally, and logistics may present occasional challenges, but obviously that will go into the planning stage when a new product is developed or marketed. Hopefully I've done a little bit of the footwork in explaining what I intend to do, but there will be contact details provided to get in touch if you've got any questions. Thank you.